Um, yeah, my name is Sheen. I work for Lego. I'm based in London, and within Lego, I am attached to the team that runs the shop.lego.com, the e-commerce platform. And as part of the modernization, the effort that has been happening due to all the cloudness and digital transformation, so we are also migrating the legacy e-commerce shop onto a cloud-based serverless architecture. So the talk here today is basically what made us to take the journey, and what are the processes we've been through, and what are the lessons we learned, and where we are trying to get to. I mean, I have quite a few slides, but I think limited time, so I may skip fast few slides, but I will stop when it is necessary to discuss the important things. So before I get going, huge thank you to the Milano team. So inviting us all here today to have this, make this day wonderful. I'm going to start with a promise. So this is good. I'm not going to give a definition for serverless, right? Because we beat serverless so hard today, it's so hard to come up with a definition. So serverless has become definitionless, right? Okay. Now, let me start with a sales pitch. So we had Jeremy talking today. So this is his weekly newsletter. So if you are in the serverless journey, please subscribe to it, because he has tons of details in it. But there is a trap. The trap is, because he packs so much into a weekly newsletter, you will never get out of it to read something else. So you will read first article, come back to it, look at the next one, so nice, so you want to read that, so you will keep going and going. Guess what? Before you come to the end of the newsletter, there's a next week's, in your inbox. So the whole cycle starts. But once, a few weeks ago, I did manage to get to the bottom of it, and I found this quote by Gandhi. I have no idea in what context and why Jeremy put it in that weekly newsletter. But that triggered my memory, and one of the presentations I did at Lego a few years ago was basically urging them to move to microservices architecture. And in that particular talk, I used plenty of motivational phrases and things. So the one that Jeremy put reminded me of this phrase I used in that talk. So this happens all the time, including myself have raised the question, why we need to do this, why? Because things are all working fine. Why are we trying to move to cloud and doing all the serverless and wasting money and everything? But that is the reality, especially if your organization is thinking of moving to serverless or in the process of going to serverless, you will get these questions. You will find the resistance from within your team and outside. But once you've gone through that, everyone wants to know, how did you do that, right? But in that the presentation, I also used this phrase. So everything starts with a simple step. No matter how big is the project or how big is the implementation, has to start somewhere small, okay? So for us, the first step was a trigger point and an organization-wide discussion that triggered this journey, which happened during the Black Friday, Cyber Monday 2017. So this is an abstract view of the legacy platform we have. So ATG, 10 servers, 8 servers talking to the same database as SAP in the back, because SAP still holds the source of truth for everything. And SAP goes to a tax system, which again, on-prem. This is specifically for calculating the US and Canada tax. So while while preparing for the event, there were concerns that it may fail or it may go through, et cetera, et cetera. But in the end, with some assurance, we went on. So Black Friday, Cyber Monday, as you know, it's not like a busy day kind of thing. It's like a 12 o'clock midnight vertical spike. If you survive that, you make money. If you fail, fall flat. That's it. So for us, with all the eagerness, eagerly watching, we had the spike. So guess what happened? The connection from SAP to the tax system, these two systems basically sitting next to each other in the on-prem hosted data center. So that hot up, so that failed. So then that took SAP down. So SAP being down, even though ATG, the e-commerce platform, had a mechanism to work offline, I don't know what happened. All its thread exhausted, went down. So shop went down immediately within few seconds. We were flat for nearly 2 hours. So that means that particular peak sales period we missed. Though there were recovery made and shop came back and et cetera, but the point was that we missed the hot trading period. So this triggered quite a lot of discussion within the organization. Things like, if there is a tax system, why do we rely on SAP to go to the tax system? Why can't the e-commerce platform go to the tax system, et cetera, et cetera. At the same time, we also found that that tax system had a scalable cloud presence. So after a few months and a decoupling, so we still have the e-commerce platform. And what we did was we started using the cloud-based tax system from the same vendor or same company. Now, the question is, how do we get from the e-commerce platform onto the tax system in a simplest possible way? Because by that time, they're already trying to replace the tax system. So we didn't want to do any development, big developments there, et cetera, et cetera. So after some brainstorming and idea discussions, we came up with this simple solution. Okay? Why don't we look at cloud, have a simple API, have a Lambda behind it, and just use it? So once done, depending on whichever platform we move to, we can just throw it away. There's no expenses. So that was one of the decisions we made and put this one in place. So this was our first step or the trigger point to move to serverless. And then came, obviously there were other business reasons in terms of modernization, going to new countries and supporting different features and moving away from the monolith, et cetera, et cetera. And with that in place, we came up with certain principles. So at that stage, we decided we want to move to cloud and serverless. We went around to various meetups. In London, we have the pleasure of having serverless meetup, AWS user group, and various other things. So we went around, spoke to people, met with similar the colleagues from other departments or other companies doing similar things. So then we thought, okay, let's do it. So before we went on, we set up few basic things. So as like a guardrail. So, if anyone questions, we say, okay, this is what we decided and this is what we're going to do. So bunch of noticeable things here: serverless managed services. So these two play crucial part when we move to serverless. And then, so here is a very high-level architecture. I'm sorry, I'm trying to go fast a bit. This is very top level, so it may not make much sense. But there are 3 parts to it. The part here with all the orange Lambda boxes or the service layer, which I will be talking today. And the one between here is we have a graph layer, and then all the front-end applications on Node, and they are running in the graph and the Node are in Fargate now. And if you look at the microservices layer, so this is roughly what we have. There are a few more, and these microservices, they communicate between themselves via APIs or events or messages. And we try not to invoke a Lambda from another microservice or from here, avoiding all those sort of tangleness. And this is roughly some of the things we have. I think probably we have 30–40% more than this. So what process did we started to follow when we launched this thing? So we looked at the shop, which is running shop. So it's always difficult migrating a running money-earning e-commerce site. So we decided we will split into 2 phases. Okay, so that means we will have the legacy platform running. Also, we will have the new e-commerce platform running as well. So in the phase 1, we targeted the products, the event streaming, and obviously the tags that I showed you earlier. And in the phase 2, or the harder parts, the checkout and the customers, promotions, rewards, and all those kind of big boys in the second phase. The second phase should be out in a few weeks' time, so we are getting closer and closer. And then we followed the standard Agile Scrum approach, but sometimes we move away from the textbook style and we just make it practical. Whichever is practical to us, we follow. And we split into 4 squads. Not necessarily you think of the the feature squads. These are all, no, we thought that wasn't going to work because the amount of knowledge in serverless, Lambda, AWS at that time was low. So we couldn't take a risk of splitting the team into feature-based teams and trying to fit an expert in every team. So our focus was to set up dedicated squads for checkout and other things. And the one in the yellow, the services team, so that squad is the one focused more on Lambda, serverless, AWS, all those things. And DevOps and automation. So when we started, we didn't have, obviously the knowledge was less. And also the infrastructure engineering team was also less in numbers. So we came to a point where we started to churn out Lambda after Lambda, but then when we came to deployment, we had to rely on infrastructure engineers to get the SQS or SNS and set up, so then they do the terraforming and et cetera, et cetera. It's not because of their slowness, it's just because the fastness of the incoming serverless implementation and the inadequate, the staffing we had. So we, as part of the sprint retro, we discussed this, and we took 2 sprints as a target and said, okay, from now on, let's share the infra task in the dev team as well. Okay? Rather than just checking it out to infra to set up the SQS and SNS, why can't we do it as part of the serverless YAML itself? Because we can also use the CloudFormation scripts as part of the resource section. So that happened, and that really pushed us further forward in terms of the speed. Okay, so if you are into this journey, please consider this. This will definitely a good thing to look into. Then we set up different accounts, AWS accounts, because that really worked well, so that we can completely separate things, and you can lock down certain things, and et cetera, et cetera. So this is something it's good to follow. So this is important. So design, review, decide. So why I say this is important is, often what we do is, we sit on a problem and discuss for hours or days. Just don't do it. Come to a sort of optimal solution, or the solution that you think is optimal, then just go and do it, right? Make a decision, just get on with it. Solution detailing, this one, if your organization has an AWS solution architect or a senior engineer who can be of design expert, this really helps. It helped in our case because we were able to, before the engineering team started to set up or got going, we were able to come up with certain detailed designs with all the So this is going to be a Lambda, here is an API gateway, all the diagrams and the details and everything. So that really helped for them to start coding or implementing. Otherwise, we would have struggled. So that gave us sort of the leeway before everyone else got on board or got up to speed. So again, if you have that sort of resource in your organization, really good, useful. Tools, nothing strange here. JavaScript, obvious choice because we already had enough skills and the resources in-house. So I would have preferred to go for Go, but for us it was a no-brainer to go with JavaScript. But again, performance-wise, it's not that different at all. With all the improvements AWS doing on the Lambda side, we hardly notice any difference. So testing, yes, we write our integration tests. They run the local offline, serverless offline, and also they use the Q environment for all the integration tests. CI/CD, an area which we still need to improve further. It's there, but it's not a single pipeline for us now. So we have a deployment pipeline going up to QA, and there is a separate pipeline deploying to production. So this will get into one stream, but still, progressing and improving. Best practices. This one is very important, cost awareness. If your team working on Lambda, they have to understand the cost factor of Lambda. Not because they're going to sit there and compute the pennies, it's because that gives them the awareness to be cost efficient or optimize Lambda when it comes to that. Because there is a huge difference between, say, I think if you use serverless, if you don't specify any RAM allocation for Lambda, it will deploy with 1 gig RAM. Whereas your Lambda may only be consuming 100 megs. So that means you're wasting nearly 90% of resource that costs money. And same with API gateway, DynamoDB, or any other managed resources you use for obvious reasons. It's always good to have the cost awareness. Managed services, I don't need to talk too much because we had enough talks today. All these things. So the second point, API gateway, no, avoid Lambda if not needed is an important point. Actually, I usually have another talk where I talk about writing less functions. This is one of the main areas I cover that because not many people, especially when they start AWS, know that you can integrate with so many AWS services directly with API gateway. There is no need for Lambda at all in most cases. Okay? So that means it saves money and effort and so many other things. Security, we can sit here and talk all day. We had enough talks earlier about securing things. The top point, the granular level policy is very, very important. When you provision Lambda, I don't usually look at all the PRs that go through in my squad. But one area I purposely, specifically look at is the serverless YAML and the way they declare the permissions. If I see anything different, so if they put, say, for example, pushing a message to SQS, say, push delete message or get message or list or whatever, I will raise the question, why do you need it? This is very important. Don't, like the earlier talk, Piosek said, don't use the asterisk at all. Make it granular as possible. And monitoring is crucial when it comes to serverless, and there are so many tools. There are so many tools. If you are in production, please enable CloudTrail, because you never know where an attack or where unintended API access or anything happens and coming from. So, okay, so engineering, most of these things are familiar to you. I am a great believer in iterative development and also start something small and then evolve. So Eric Rice, the Startup Way is a good book, has plenty of things. I mean, maybe a bit long read, but has plenty of things. So one of the things that he mentions there is start small and scale fast. This is absolutely true, and you need to believe that when you do serverless. And the other thing is, it depends on your team structure and organization. If you are starting serverless or any new technology, if at all possible, co-locate, that aids communication and collaboration, and you can get things moving faster. Okay, a few service development examples, couple of them. Set piece architecture, I'll skip past this one. So this is a term I came up with. It's basically, the idea is that when you do serverless or any cloud thing, you don't need to start from this point and build all the things to the endpoint. You can break it down. You can say domain or modules or components or whatever. So you can do that in set pieces. It's like in football, in England, they used to say set piece play. That means they don't pass the ball from that end to score the goal, because there's a foul happens near the corner, and they do a corner kick and goes to the goal. Because these things they practice all the time. So this is also true when it comes to filming or theater, where you can shoot different scenes in parallel, and then you can bring everything together. With serverless, with all the event-driven and the managed service and everything that you have, you can build these sort of your architectural small domains separately, and then things will slowly come together. So yeah, so this is what I mean. So this is what I was saying, that so this sort of set piece architecture helps you to rehearse. So you can come up with a small few lambdas, 2-3 lambdas here, an API gateway, then you can do a POC on it, you can run it again and again before you actually making into production, integrating with other services. Okay, so this is a quick walkthrough of event streaming setup we have. So if you are from the e-commerce, you know that when you go to an online shop, every click you make on the shop site is tracked, right? Which product you are clicking, is that a recommended product or this, that, etc., etc. So that is helped these days to stream to big data and do analytics and to get recommendations back to the user. So this is the case we have. So we have the events coming through, and we have sort of a certain design and business the constraints or recommendations to consider. And then we came up with this one. So on that, the event side, you have all the event producers, which is basically the shop with all the different clicks. We stream it to a Firehose, an API gateway, and that goes to a bucket, and then triggers a Lambda, which acts as a triager, basically, that will look at all the different event types, and that will then batch those event types and send to all different consumers. So we have a pattern called triager pattern. And what it basically does is we have a JSON file which lists different event types and the consumers. So if you need to stream certain event types to a new consumer, all we need is a new Lambda to act as the consumer and update to this particular JSON file, and everything else should just work. So here is another one. So how do we handle users' card data? So this is a situation. Say, for example, a customer comes onto the shop and putting few things into the basket. Okay? Now, ready to pay. So at that stage, she is seeing there is a tick box to say that, do you want to save the card details so that next time when you come, it becomes all very easier. And she is thinking of buying more things in the future. So she said, OK, I'm fine. So she gives a tick, and that card data needs to be saved, and the order gets completed, and that's the checkout flow. The thing to note here is the customer doesn't need to wait there until we take the card details and store somewhere in our backend or the e-commerce platform, do all the encryption and things. This can be decoupled. So this is a classic example of an event-driven architecture. I think when Danilo presented, someone asked the question, how is it possible to make everything event-driven? You can't. Because in this checkout flow, it's a customer-facing a Lambda and API that has to finish as quickly as possible. You can't say to the customer, oh, by the way, wait for 5 seconds until I write all your data to the backend. No, they won't wait. They will cancel the order and go away. So that should happen in the background. So that's where the event-driven mechanism comes into the picture. Then also when you handle with credit card data, there's so many restrictions. You need to encrypt the data. You need to be compliant with the PCI. You can't hold it forever. There's so many things to consider. So this is a minimized version of the architecture for the discussion today. The middle part is a card service, which is a microservice. Obviously, it has more lambdas and API gateways and many other things. So just for the discussion, I put those two things in. One lambda is to receive the request from the customer when the customer said, I want to store the data. Another one is to deal with storing the actual data to the e-commerce platform. So things to note here is, so the e-commerce platform is on Google Cloud, and the rest of the things are on AWS. So this part happens as part of the checkout, and this happens after the checkout. Okay. So let's trigger one or two ideas. You may ask, why can't that order service microservice write directly to the DynamoDB, the card data? Again, the problem is, if you ever wanted to change the DynamoDB for some reason, then you are making changes to the card service and also to the order service system, right? Same way, you may ask, why can't it talk to the Lambda? So that's, again, two different microservices. They're crossing the boundaries. There is absolutely no need for them to interact in this way, because this is not a synchronous call. Okay, so this happens once as the back of the order placing flow. So this is where we use the event-driven architecture. So the order service, what it will do is it will send an event to a topic. Okay, so it doesn't care whoever is listening to it. So in our case, the save request handler or the Lambda is listening to it. It will get the event and it will put into the Dynamo. And then what happens is we only need to store the data if the order went through successfully. If the payment failed or if the customer canceled, we don't need to do anything because that's a failed order. So for that, we listen for the event coming from the commerce platform. So that they will send out an event depending on the order status, and that will then get processed by another Lambda, which will then do the encrypt the data and store that. So we do double encryption when we store in the commerce platform. So we do a blanket encryption. Then per customer data, we identify a uniqueness from the customer, and I use that as well, hash it and encrypt. So even if you leak the main key, there's no way they can decrypt the saved data. Okay, so there's so many. Have we got time? Okay, so many lessons you can do. Principles, very important. Don't argue, just go on with a solution. Cost awareness, talked about. Proof of concept, important, especially if you want to show it to stakeholders. And act fast. I noticed Jeremy did the just do it. This slide was prepared before that, I can guarantee. So just do it, right? So just don't sit there and wait for something. And there's so many AWS good things that you may want to look into. Lambda optimization I touched upon. And data, don't ever keep unwanted data. There are so many different ways you can get it off them without you doing anything. AWS will do everything because it costs money if it sits there. Okay, S3. Firehose, yes, it's very good. You can buffer the events and before it stream to S3 or somewhere. But there are issues. I'll be here till the evening, so you can talk to me if you want to know more. DLQs monitoring is important. So what next for us? So we have a bunch of things. We need, obviously, to improve this one once we gone out live. And then there are new projects that will happen. So we have a good template here now and the experience that we can take forward. So, and obviously improving the CI/CD pipeline. I will leave you with two sayings from me. It's me saying, when you start, if you're starting new on serverless or thinking, keep this in mind. When you start on serverless, keep this in mind. No one starts perfect, okay? So we only become better as we go through. but that is vital. If you don't improve, if you keep on piling your tech debt, then you finished. Okay? Start something, then keep on improving. Because once you started, once you gain the experience, this is what you will see happening. Okay? Because then there is no stopping. You are on cloud 9 and going faster and faster. That's all I have. Go build serverless. Thank you very much.